Good morning, everybody. We would like to start another aspect here of the work that we need to do with the Open Daylight community. And we want to talk to you this morning about an optimized vSwitch in order to, there are going to be two of us, Brian, who's here, and my name is Uri. And we are going to, after the legal disclaimer, talk to you about a few subjects here. Before we actually dive into the vSwitch, we would like to put things in perspective and start from the bigger picture and then zoom it down as we go. So bear with us on this, and then we'll go dive into some of the technical details of how we see the vSwitch gets supported, promoted, and handled by the Open Daylight community. So starting from some lofty concepts that are swirling around in the industry, different companies have different names for that, but one thing probably we should not mistake about, which is the fact that many of us, due to, I would term that as cloudification, we would like to see that the infrastructure becomes a little bit more automated, a little bit more dynamic, agile, and ready to change on the spot based on an application requirements. For those of you who attended the Northbound API panel yesterday, that would be a little bit clearer that whatever happens up there in the north is not yet fully clear for anyone. And it would be fair to say that as an industry, we are on our first steps towards complete automation of all of those aspects that today are siloed of the infrastructure, compute, network, and storage. But some of the work that is already happening today in Open Daylight, you could look at that as a precursor, or maybe a little bit more than that, on that very large experiment that we are all conducting together of trying to convert the infrastructure in that way. We do see people driving towards policy-driven orchestration. As we do that, we need to take into account that in order for this to really yield the improvements that we are all seeking in terms of TCO, CapEx, and OpEx, we need to have that conversation happening both ways. So when we are trying to do something policy-driven, it provides an opportunity, an advantage of abstracting some of the details. We would like to abstract the annoying details and actually use and benefit from those details that we really care about. So there needs to be some interaction between the underlying infrastructure and its specific capabilities and the demands of whatever application we want to have on top. So when we talk about this cloudification, on one hand, we all hope that it allows us to see more application evolving in this infrastructure and really helping all of us deliver faster, better, more innovative products to our customers. At the same time, we need to see what it means for the underlying infrastructure. And remember, we are going to land on the vSwitch in a few minutes. So let's put it a little bit in a narrower perspective. I'm looking at two examples. On the left side, you could see some of, and we a little bit selectively picked some of the elements of the emerging architecture out of the ETSI NFV efforts. Pretty much, for those of you who have not attended the keynote yesterday, this is the telco industry looking at cloud infrastructure, trying to adopt that to the needs. You see on the top the existing elements of OSS, BSS, which are the core of the telco operating systems today, and underneath that, let us put some dynamic new infrastructure that it is taking after cloud, benefiting from the lower cost of ownership that cloud infrastructure offers, and for the faster, dynamic, automated ability it presents. On the right side is somewhat classical, if you could refer to it that way, cloud multi-tenant environment where I have multiple VMs, not necessarily owned by the same application, by the same tenant. And the other thing that we would like to see happening over there is network appliances starting to pop up as, I would call it, the second wave of the SDN. In the last few years, as an industry, we were busy with L2, L3 coming to play. And now, as the second wave, we are starting to see the appliances showing up too. So talking about those appliances, what we are really witnessing, and different people have different diagrams, but it all means the same. We are going from existing independent physical boxes that has served us very well so many years, but also has all sorts of limitations. They do not have the separation of control and data. They do not lend themselves to move around in the infrastructure. I place them in one location, and now the traffic needs to get to them. As we have more and more traffic that is really going east-west, inter-VM, multiple servers that are sitting on the edge, and they would be constituting together a complete application. The fact that I have some existing boxes some places and I need to send traffic over there is going to be limiting my scalability potentially. Also, many of those boxes are not really designed for multi-tenancy. It's not easy to share those resources. And we all grown used to the agility, flexibility, live migration that is offered by the virtual machines. So with the appliances moving over, we're getting closer to that little bit of a dream from a few years ago where all of my network assets can now be moved and automatically provisioned exactly at the same ease that I was getting used to in the last few years with virtual machines. So, but let us not forget that as we all take this, hoping to get faster, better, cheaper, there are three elements that need to be taken care of. In the orchestration, and the specific example that we'll talk about, which is the example used by the OpenDaylight community, it's really an example used in many other places, is an open source example with OpenStack. OpenStack itself needs some enhancements to support notions of virtual machine as appliances. We are working on this as part of the community. With management, I refer here to the network specifically. And so there is work that we need to do as part of OpenDaylight in order to enable that kind of a notion too. And the last element here is performance. And it's not only performance, but just trying to capture it in one word, that really relates to the capabilities of the end node, the server, really as a gateway into the network. It's really about the vSwitch. So we do need to work on all of those elements. In this talk this morning, we are going to really shed some light on what is needed in the vSwitch. So why are we really talking about the vSwitch? Here is a little bit of a cartoon-like diagram of how it all stacks up. And don't worry, I'm not going to stay at this level. We are going to get a little bit more detailed and a little bit more technical. But basically, we have some application. And the application is trying to get some contract going on with the infrastructure. Call it SLA, call it policy. Again, go to the northbound API, fun conversation. Different people have different notions how this is going to work. But it's clear that we want to have some sort of a contract. And then I could have some cloud operating system, cloud management environment, whatever you want to call that. Again, OpenStack as an example. And today we are really focusing only on the network. But similar exercise is needed for storage and for the compute in order to bring this together. For shortage of time, we are not going to talk about that today. And then as we go further on our travel southwards, the OpenDaylight, and the OpenDaylight is obviously interacting with the vSwitch. So the vSwitch is really the new interface between what used to be the physical server and the TOR. That boundary has now moved to the server. This is not news to anyone. It is simply taking all of us a little bit of time to absorb that and take the necessary action. That movement of that interface means that you need to really worry about aspects of configuration and management. This is the place where you go and impact how your servers, now VMs, and appliances are interacting with the network. Today, if we take a snapshot of where OpenStack is today, for instance, they are starting on insertion. So you could insert one appliance, but you don't necessarily could create some ordered series of appliances and put your VMs in a convenient place in that series. And I'm avoiding using the term chain because everybody here knows what service chain really means, but it's the same notion. So obviously there is work to do. But as you place an appliance like the one we are showing over here, then you need to make sure that the vSwitch is aware of that because you may need different performance, you may need different privileges for that specific appliance if this is to be part of the infrastructure versus some specific virtual machine that is only related to a given tenant and therefore only has access to that specific tenant network. So we need to be aware of those. And obviously, it is the place where the controller interacts with the compute, and we are going to dive much deeper into that. So we need to have that two-way conversation. We need to have a way for the infrastructure to expose its capabilities. I may have one server that has a little bit more hardware, more memory, more accelerators. I may have some application that has some demands for more security processing that may be well met with a server that is so equipped so it could offer those services. And this is part of the work we all need to do. What is changing now in the vSwitch? We have vSwitches, we have many of them, actually maybe too many, that is software-based, and different people are building different vSwitches. This is taken out of the open vSwitch.org, which is a project that is supported by OpenDaylight, would be really the focus of where we want to take it as a starting point and improve the functionality and the performance of the vSwitch. And I just want to bring to you a few aspects of what is changing in the vSwitch. So, for instance, we are all talking about increased east-west traffic because applications are really deployed as multiple virtual machines on multiple servers that may reside on some racks, etc. So when you think about that, you're really talking about inter-vSwitch traffic. that starts from some VM, goes through a vSwitch, through a NIC, some TOR if you're using them. And so we need to be aware of the vSwitch component when we talk about that. If I have an infrastructure piece, like a network appliance, that infrastructure piece, exactly like the standalone physical appliances, may require some significantly more traffic. Part of the promise of this whole dynamic, agile infrastructure is that I don't need to be picky and choosy about whether I'm going to put the appliance here or there, and my demand would also change in quasi-real time, I would say. So if I have now lots of security processing required in this particular rack, I don't want to be limited by my choice because, oh, over there, I don't necessarily have the right performance. I would like to have adequate level of performance, and this is something we all need to, at some point, agree what that level needs to be. But I would claim that it is a little bit higher than what we get with the Linux bridge today, and that with limited investment, we could get very high rewards. And this is where we would like to move the ball forward and really improve the performance. So when you see, and the functionality, and when you have some placement decision to make, where would I like to put that VM that is either high demand by itself or a piece of the infrastructure, I would not have to say, oh, it's only there that I have the adequate resources, and then I find it located relatively far away, too many hops from where the consumers of that appliance may be. We also want to think about the fact that sitting here, beginning of 2014, some people already ship 40 gig. You will find servers equipped with double 40 gig very soon. We all know that 100 is already on the heels of the 40. So when you have, and the number of cores is also increasing. And again, number of cores increasing means more VMs, means the density could go higher, the inter-VM communication, either local on a server or going between servers. So I need to be ready for that. And talking about more cores, more VMs on a given server, it also means that I'd like to have my appliance right there. Why would I take my traffic out of that server, send it to another rack just to get some service? I'd like to have that ability. That is not to suggest that the model of physical appliances or the need for high-powered appliances or some bank of appliances or services that I would like to centralize in my infrastructure goes away. For some cases, there's going to be need for that, and we all need to be ready for that. This is not to suggest that this model is the only one. This is only to suggest that this model is of value, needs to be actually optimized, and that's the work we need to take. And one thing that is important is that when you compare numbers, and I apologize for not having numbers today, we are going to roll out number as we roll out products and technology, but it's a little bit premature right now, and we need to wait for such day where this whole work is completely integrated with OpenDaylight and that we could actually test that. But as it is right now, and we have many numbers, and anyone here in the audience who played with the existing vSwitches knows exactly the limitation. And the technology we want to show to you today is about a 10x relative term improvement, depending on what you're trying to do there. So that was the case for the vSwitch. Now, let me move into how this whole stack integrates with OpenDaylight. Starting from Neutron, you have multiple options. OVS can plug directly over there, but as a community, we are migrating towards the ML2, where OpenDaylight, with the Hydrogen release, now have the OpenStack services with multiple options as an overlay manager provider underneath that. One of those that is integrated into the OpenDaylight controller is the OVSDB Neutron. That really could be thought of, and some of this work, very happy with the community support and collaboration that is going on with the key guys of OVSDB, Brent and Madhu, with some of the Cisco guys who are working with us on the OpenFlow plugin. So it's really nice to see that. With the Hydrogen release, I have an overlay manager that is integrated. It takes advantage of these two plugins that you see at the south, where OpenFlow plugin really manipulates the data plane, and the data plane in our case is really the vSwitch. And the OVSDB adds the necessary configuration options. So with manipulating both of them together, and I show them here very, very basically so that you see that there is a data path separate from the configuration. And the next slide, again, is going to drill down and give you a little bit better, more perfect view of the reality there. So we actually create a nice little triangle here. OpenFlow plugin, OVSDB plugin, and the vSwitch. And I think as a community, we would like to strengthen that triangle, make sure the triangle is really optimized for performance, balanced for functionality, so we have all the support we needed. And we are not there yet. We do have some functionality pieces that are still needed in order to make that triangle really look perfect. For instance, ARP, DHCP, support, really matching performance and features. Another thing, just to give you a sense and connect it with other projects that are going on in OpenDaylight, is the notion of policy, tying back to the beginning of this talk when I was mentioning the idea of infrastructure automation, policy-driven infrastructure. And it first showed up in OpenStack, but very fast after that, pretty much the same policy structure and architecture shows up in OpenDaylight. And the logical next step, just with my one eye to the clock here, is that it needs to proliferate down into the south too. And the question mark is not to suggest that we have no idea. It's really to suggest that as a community, we need to work together and agree in what way is the higher level policy need to manifest itself in the infrastructure, what is the right level of primitives that we would need, say, in a vSwitch, in a server, in the plugins. Bear in mind that the level of details and the abstraction does change as we go from the top to the bottom. At the top, I would express something in a language, in a policy that is understood by a potential user, by a potential application. At the bottom, I'd like to express it in those terms that we all like and love so much as bandwidth and latency and jitter and whatnot. This slide, provided by Brent and Madhu, really is showing the same thing a little bit in a more detailed fashion. We are seeing the same structure here. It gives you the next level of details. If you're interested, go attend some of the talks over there. You simply see that we have two types of service abstraction layers, the ADSAL and the MDSAL. Some work with OpenFlow 1.3 is going on this side. The OVSDB actually plugs on the other side. That enables the configuration service to be available. And we really want to focus on what work is needed on the vSwitch itself. And with that, I hand it off to Brian.
Thanks, Uri. So I'll be talking a really focusing in on what we're doing with the vSwitch, what we have done, and give you some ideas of where we're going. I want to be, highlighting some of the advantages of what we're doing, but not, paper over some of the issues that might arise. So, for those of you who may not be familiar with the data plane development kit, so we realized a number of years ago that trying to build a high-performance packet processing capability on IA had a lot of challenges, and so we developed this framework, this set of libraries called DPDK, Data Plane Development Kit, that addressed most of the common issues surrounding packet processing in the compute in software. So, and of course, it being part of Intel, we optimized it to work on IA, on Intel architecture. So, for example, we have things like ring structures that can efficiently be used to pass pointers to data structures back and forth. We eliminated all the locks that we could, and one of the key features is this poll mode driver. That's the Intel DPDK PMD down there at the bottom. So it's all about getting packets into a place where they can be used by software as quickly as possible. And it does bypass the Linux stack as you'll see as we go through, which causes some issues depending on what you're trying to do. But it's all about trying to get that maximum performance edge and running in an IA kind of situation. So we've got scalability where we do support down to the low end on the atoms all the way up to our high performance Xeons. So the approach we took with our accelerated vSwitch was we wanted to keep the open vSwitch daemon as untouched as possible. So what we did was we've got a DPIF going to our DPDK, and so that wasn't new. This is something that was already in the daemon, and we rewrote the rest of it to optimize the flow of packets off the wire and getting them into VMs. I'm going to go through kind of what each of those interface types is in a bit more detail, but the key is that we use things like huge page tables, so we're able to get allocate large contiguous pools of memory and use that to transfer data between the packet forwarding engine and up to VMs is one option. And I'll go through the different options because it really depends on what you're trying to do. What is this problem you're trying to solve? Are you just trying to get things as quickly as possible into a VM? Do you want to have all the various options of supporting things like legacy VirtIO and all that? So we'll go through those. But before we do that, why don't we first go through a day in the life of a packet. So if we start off, we've got our control plane, so the switch daemon, vSwitch daemon, and our accelerated DPDK data plane. And a packet comes in, and let's say it comes in, and the first thing that happens is we do the hash, and we look for the flow entry. And we go, oh, we don't have this flow. We've got the hash key. It doesn't match anything we have. Therefore, we need to go and kick it up to the OBS daemon. So once we have that, then he can then look at that and go, oh, do I have this? Because if he doesn't, then there's the interaction with OpenDaylight as an example. But in this, let's assume that he's got that entry, and then he can. Next step is he's determined, oh, well, what you do with this one is it came in on port 1, you're going to output it on port 2. So then he passes that action down to our accelerated data plane, and then from now on it is cached in there. So that's from now on you've got that fast path. So what we're doing there is actually fairly similar to the way Open vSwitch already works with when you look at what happens, the interaction between the user space daemon and the kernel data path. Now, of course, because we're doing all this with our DPDK and we have a separate process, we can do it a lot faster. And the other key, of course, is that pull mode driver. So we're able to get things into that accelerated data plane that much quicker. So when we look at sort of the bigger picture, let's start, step back a second, and then we'll kind of deep dive a bit. So if you have OpenDaylight up there and you're setting up your flow table entries, and so this Open vSwitch daemon, we're able to keep as is without modification. We implement a DPIF, data plane interface, to go to this DPDK vSwitch. Now, as I mentioned the pull mode driver, so he's coming in, pulling things off the wire, going into and then going through the packet forwarding logic. What's actually happening, and you kind of saw it on the previous foil, is it's actually going into shared memory. So this is a pool of memory. It's huge page tables. So you can, and it's configurable how you set it up, but we'll have a very large set of memory that we then, when we're going through and doing the actual packet forwarding, we don't need to copy the packet back and forth. It avoids a lot of the copies that can happen. If you're going to what we're calling here a data path virtual machine, so this could be potentially some sort of virtual appliance. Uri mentioned, looking at NFV kind of use cases. There might be virtual EPC, virtual BRAS. There's all kinds of use cases from that side of the house. But also, in a virtual appliance use case, you can have now Intel DPDK or your favorite DPDK running in there and be able to take things off the rings. So this is supported right now. We've got, I should point out, we've got this code. It's available right now on 01.org, so you can download it and play with it. And by getting us into that data plane as fast as possible into that VM, that makes a lot of sense depending on what you're doing. However, you notice what we're doing now is, because it's a zero copy interface, we came into the shared memory region, and really all you have to do is pass a pointer and say, hey, your packet's here. Now, depending on what you're doing, you might say, well, there goes my security, right? But that's where you've got to look carefully at the needs of your VMs and your applications and say, well, is that what I want to do? So if you're doing something like a firewall, for example, then, or intrusion detection, then that might make sense. But we recognize that, hey, it doesn't always make sense. But that's for an application that you're willing to, do that extra bit to get the best performance. KNI, so that's the kernel network interface. This is another way that we've optimized things to use DPDK. So it's really, it's DPDK underneath that KNI interface. So you can have if you're writing to sockets, you can have your application unmodified, but now you've accelerated things underneath that, and you're able to get, again, it's that shared memory model. Now, people say, but my application, I want the security, I want the portability, I don't want to have to rewrite anything, I don't want any modifications whatsoever to my virtual machine. And it's like, okay, we hear you. So the path on the leftmost there is using stock VirtIO and the QEMU backend that's supported sort of out of the box. It just works. Now, what we found in going forward with that was we weren't really able to demonstrate the benefits of all the acceleration we did down here, because then it bottlenecks going through QEMU and the sort of stock vhost interface. And I'll show in a minute kind of what that looks like. So what we did was we said, hey, okay, let's try to have an accelerated vhost path as well. So the advantage there is we're able to keep an unmodified virtual machine, have that so you got the VirtIO, and we do the acceleration kind of underneath the covers. And it's an unmodified VM, so it just works. Now the performance gains we're seeing with that are pretty good. Now, it's not released yet. This is work sort of in development, so it will be released, and I can't really say that's where the lawyers kind of do the arm twisting, and nor can I give you a number right now, but I think the technical term is kick-ass. So, looking at kind of all these different interface types and options that we have, I think, and I'll go through some more of the details, but I think what it's all about is giving people that capability to choose for themselves, what they want, which trade-offs they want to make. So a couple things. I mentioned that code is on 01.org. Wind River, I know, has a commercial offering through that. Some of our friends over here in the front row, 6Wind, they've got something that they've got, and it's not exactly this, but and I don't know if you guys have a session on that, but so there are some various options there as far as using DPDK to accelerate your virtual switch. The other thing I should point out is once you've got this very high performance packet forwarding engine, it opens up the opportunity to do more and to add in additional things that you might want to do. So an example might be with Cosmos. We did some proof of concepts in integrating their DPI engine into this sort of whole framework. And then we were able to do, and we showed this at IDF last year, we were able to show, for example, doing the DPI and then using it to affect the quality of service on the individual flows. So that's just one example of the kinds of things you can do with this framework. I mentioned this accelerated vhost, and so, and this is, it's not released yet, but the whole key is by emulating, we've got the rings set up on the VirtIO driver, and we've on the back end, we've got this whole DPDK back end that uses all the techniques, and we had to create sort of our own event FD sort of device down there in the kernel, and all that will be released to the open source community. So I think it's important to look at, okay, across the broad spectrum of all the kind of interfaces I've talked about, what's the, I wish I could give numbers. As already said, we're working on a sort of a set of numbers that can be released. But, so I can talk to it qualitatively here. Because it is open source on 01.org, you are able to download our open vSwitch. So just looking at the kind of various options we have here, we've got our, the one on the left there, so that's the sort of the stock vhost backend. So everything works, you're not modifying the guest, all that. But the good thing to point out is now when we accelerate it, you've got all that goodness. However, now you can do, like, the number of copies is reduced, and the performance is much higher. It wasn't just the copies, so we only reduced the copies by 1. So it's like, well, you might say, so what? But it's really the back and forth to the kernel, and there's a lot of calls back and forth, and we've eliminated a lot of those. So that's kind of the key takeaway on that, is we're seeing much higher performance with that approach. Now, when we talk about hypervisor compatibility, what are we talking about there? So what we mean is, if I'm working with OpenStack, how can it work? We're looking at the various hook points into the OpenStack. OpenStack creates some additional challenges if you look at how you go from the vSwitch up to the VMs and going through the Linux bridges. So that's something we're working on and looking at as well. But we're all about offering choices and giving people the means to make those trade-offs. Looking at so this is IV shared memory. That's what the IV SHMEM is. So that's the one where okay, you can have a BSD sockets API if you want with that KNI driver I mentioned, but you don't have the guest isolation. So depending on what you're doing, that may be a killer. It may be just ruling it out. So I want to be upfront about that. However, there might be an application, let's say a firewall intrusion detection IPS, where you go, well, I've got to trust my firewall. If I don't trust my firewall, well, I may as well just go home. So that's, you're not going to get a better performance than doing a zero copy. So it's all been about, offering choices to our customers and letting them configure it. Now, something to keep in mind, let's go, okay. When we compare what we've done with our accelerated vSwitch with the open vSwitch that's out there today. So this is sort of stock. I'm just trying to represent stock open vSwitch here. This is nothing modified here. You look at what we've got on our website with the 01.org and the community that's around that. And we're working to maintain feature compatibility. It works actually with OpenFlow, with OpenDaylight, and in fact, I see Craig Griffin and Chris from Wind River. They're going to be talking in about a half hour about the details of some of the work they've done on that, and I think that's in Ballroom D, a couple of rooms over. So if you want more details on what they've been doing there, then I'd encourage you to attend that one. But so if you look, though, about, compare and contrast with what Open vSwitch does today, well, the feature list, and it's a moving target. There's always new features being added to Open vSwitch. So we wanted to also give people an option and a way to use some of the DPDK goodness that we have, the DPDK libraries, and give an alternative path, another way of kind of alternative architecture. So this is the part of the talk where I say, and one more thing, but I'm not wearing a turtleneck, so it doesn't impact the same way. Okay, so what's the one more thing? Well, you notice that convenient empty space in the diagram. Well, we just had to fill it. Nature abhors a vacuum. So what we did was, and we've been working with the community on this, and this is recent. This is last week, so this is brand new. So what we did was we took in those DPDK libraries into the Open vSwitch daemon. This is running as a single process. It's using those libraries, so you've got the features that we talked about, like, for example, the poll mode driver. And we created a DPDK netdev. Now, because it appears as a netdev, it kind of plugs into the whole framework. Now, if you sort of follow the bouncing packets, and I didn't animate it because personally not my forte, or anyway. So if you follow the packets coming in through the wire, it comes up through this path. Now, if there are features that you need, for example, we haven't implemented VXLAN in our DPDK yet. So you can then have the calls down to the kernel to do those kind of features. This is a point-in-time thing. This just happened last week. So I encourage you to look. It's a patch right now, so it's in the dev branch, actually. And the advantage is we're able to get much better performance at this end. It's still single-threaded, so it's limited by that. Now, plans are afoot to address that. That's sort of the obvious first thing to address, is make it multi-threaded. So it's not going to, if we compare and contrast this with the previous one I was talking about, you're going to see the performance is not really there yet. However, this gives an alternative path in working with openvswitch.org as opposed to going to either 01.org to get Intel DPDK. 6Wind has their DPDK.org that they're working with a community around that. Wind River's got their stuff as part of their OVP. So this is just another path. The advantage of this is in terms of upstreaming and that kind of capability, it'll be more broadly available. I think the key, one of the key takeaways I want to give you is in all of these solutions, what we're doing is keeping that control path and the thing that talks to OpenDaylight the same. Now, I'm not saying there's no bugs in our stuff, but it's by keeping that the same, it kind of gives that OpenDaylight goodness and being able to control it, and it's really a good way of approaching this and giving people the choice of, well, what vSwitch do I want to have in here? You know, and I mentioned some of the options, and there are trade-offs, you know, involved. So anyway, with that, I'll pass it back to Uri and let him close it out.
Okay, so to wrap it all up, I think there is an important opportunity for all of us to work together to optimize the vSwitch to create that strong and balanced triangle, connecting the servers at the receiving end, but also at the servers as an entity that needs to communicate both ways, not just provide network capabilities, but also express its capabilities into the infrastructure, be it network, be it storage, be it compute. Some of it is happening in OpenDaylight. Some of it is happening in OpenStack. There is a project proposal that, together with Wind River, we uploaded to OpenDaylight. That's going to be discussed later this month. As you saw, we are working on enhancing the performance with DPDK. There is support from the community. Specifically last week was a very interesting event where the maintainers of openvswitch.org accepted a DPDK patch that allows DPDK to run as integral part of the Open vSwitch. So you could go look at that if anyone wants. It's on the mailing list, but if anyone needs a pointer, contact us, let us know. And we also would like to encourage the community to work together so that we put in front of the industry somewhat smaller number of options. If we could agree and drive convergence, and convergence doesn't necessarily mean one. Convergence means that we would all have a small set of efforts that are identified, agreed to, and so that we would actually help make the combination of orchestration, SDN, and servers be as powerful as they could be, so we all benefit from that. Thank you very much. We have little time for questions, so let me open the floor for that. Any, yes?
Yeah, any thought, you talked about horizontal data plane applications early in the talk. Any thoughts about things to be done regarding isolation and determinism?
So let me repeat the question for the benefit of everybody and also make sure I understood it. The question is about horizontal applications and how we can maintain isolation as we do that. And so when you say horizontal, you mean on a given server or a set of servers? Yeah, so I think Brian touched a little bit on that in his part. We actually support industry common mechanisms for isolation right now. We believe also that security is very important in all of this shared infrastructure, and you'll see more from us going forward. But right now, what we are doing is we are providing you the option. You could stick with the abilities that we have right now, hypervisor-based isolation, data path isolation, and maintaining your trust model. Or if you want to deal with an infrastructure element, you could make a choice of performance versus security. As Brian pointed out, you know, the shared memory may be a no-starter for some folks, so that's why we are hard working on other options that do not require that, but there is a give and take. There are other key things that could happen in the VT technologies to make that even better, but that's beyond the scope of this talk today. Any other questions? Yes.
Is SRIOV capability anywhere in the roadmap?
That was a slide in the backup that we kept just for you. Do you want to comment on that?
So yeah, SRIV, something our NICs support. There are some customers. Let me put it this way: there are some customers who are interested in using that model, and there's nothing really we talked about that would break. Because if you think of it from a overall data path perspective, if you want to have that isolation in an isolated VM running completely its own stack in another VM, yeah, you can use SRV and kind of come back through. And in fact, we've done some prototyping where we use our Niantic and use VM to VM, sort of going through the Niantic. So that's one approach, and that gives you the isolation, and that's probably why people were interested in SRIV in the first place. Now, if they don't want to do that, then that's where some of the shared memory models might be of interest. But yeah, definitely, that is something I know some people are doing, and we've actually got some demos that we've done with it through IDF, and I think, yeah, so IDF Beijing's our next upcoming demo opportunity that we'll be showcasing some of those solutions.
So just had a short comment about that. Anyone who's interested in that, please contact us. We'd like to understand in any of this stuff. Definitely would like to understand what people would think is necessary, specifically to SRIOV. SRIOV had some sort of ambiguous kind of support from for the broad industry because obviously it bypasses, maybe it bypasses a little bit too much for some people. We believe that for some application, you do want to have as direct as you could go, but maybe there needs to be a little bit of a fresh thinking how you do that, add some mechanisms around it to make it a little bit more palatable. So we're working on this. It's a bit too early to go into details, but for now, what we were trying to show here is that there are multiple options. You get to make your own trade-off, whatever you like. SRIOV, actually, we are working, part of the OpenStack effort we are involved in is to expose NICs that have those capabilities. There are others in the industry that are pushing that too, so I do not think that SRIOV is going away. At the same time, as it is right now, it probably has some limitations that prevent it from becoming mainstream or the only way people want to do this. So it's one of the tools in your toolkit, and some people use it. Any other questions? Yes. Yeah. So
yeah, that was an example where I was talking about, in that last model I showed, where VXLAN, for example, yeah, it could work with that. Yes, absolutely, out of the box. Now, you will suffer a performance penalty because of the way it's implemented today. But that's definitely something that over time we want to accelerate and get into our sort of overall accelerated path. Now, on the earlier model, the one where we've got an entire DPDK data path, it's not supported today, but it is on our, we're looking at it.
So we obviously fully recognize the need to do that. It's just a question of execution, and we'll get to it as soon as we can. It's obviously a critical feature.
Yep.
Okay, thanks everybody so much. Today, that would be a little bit clearer that whatever happens up there in the north is not yet fully clear for anyone. And it would be fair to say that as an industry, we are on our first steps towards complete automation of all of those aspects that today are siloed of the infrastructure, compute, network, and storage. But some of the work that is already happening today in OpenDaylight, you could look at that as a precursor, or maybe a little bit more than that, on that very large experiment that we are all conducting together of trying to convert the infrastructure in that way. We do see people driving towards policy-driven orchestration. As we do that, we need to take into account that in order for this to really yield details of how we see the vSwitch gets supported, promoted, and handled by the OpenDaylight community. So starting from some lofty concepts that are swirling around in the industry, different companies have different names for that, but one thing probably we should not mistake about, which is the fact that many of us, due to, I would term that as cloudification, we would like to see that the infrastructure becomes a little bit more automated, a little bit more dynamic, agile, and ready to change on the spot based on an application requirement. For those of you who attended the Northbound API panel, yes, the improvements that we are all seeking in terms of TCO, CapEx, and OpEx, we need to have that conversation happening both ways. So when we are trying to do something policy-driven, it provides an opportunity, an advantage of abstracting some of the details. We would like to abstract the annoying details and actually use and benefit from those details that we really care about. So there needs to be some interaction between the underlying infrastructure and its specific capabilities and the demands of whatever application we want to have on top. So when we talk about this cloudification, on one hand, we all hope that it allows us to see more application evolving in this infrastructure and really helping all of us deliver faster, better, more innovative products to our customers. At the same time, we need to see what it means for the underlying infrastructure. And remember, we are going to land on the vSwitch in a few minutes. So let's put it a little bit in a narrower perspective. I'm looking at two examples. On the left side, you could see some of, and we a little bit selectively picked some of the elements of the emerging architecture out of the ETSI NFV efforts. Pretty much, for those of you who have not attended the keynote yesterday, this is the telco industry looking at cloud infrastructure, trying to adopt that to the needs. You see on the top the existing elements of OSS, BSS, which are the core of the telco. Good morning, everybody. We would like to start another aspect here of the work that we need to do with the OpenDaylight community. And we want to talk to you this morning about an optimized vSwitch in order to, there are going to be two of us, Brian, who's here, and my name is Uri. And we are going to, after the legal disclaimer, talk to you about a few subjects here. Before we actually dive into the vSwitch, we would like to put things in perspective and start from the bigger picture and then zoom it down as we go. So bear with us on this, and then we'll go dive into some of the technical details.